Hello and welcome everyone, and thank you for your patience. We're ready to go here. I'm Jim Olson, Assistant Executive Director of the NTCA. Thank you for attending this webinar. Today's webinar is titled Opportunities and Challenges in Exterior Tiling, and it's sponsored by MAPE. But before we begin, I do have a little business to take care of. Today's webinar will be muted. Please use the participant feedback or the chat screen on your computer to ask a question. Just type in your question and we will answer them at the end of the presentation. Also, this presentation is accredited by AIA and has a one-hour CEU available. If you'd like to request the CEU, please watch the chat screen and I'll give you a couple of email addresses to send your request to. All of our webinars are archived and available to watch at any time after the webinars are presented. Please email your request to me, and again, I'll provide my email address on the chat screen once we begin. If the audio on your computer is poor, call the number on the chat screen to listen on your phone, but please mute your computer then. Today's presenter, Jim Whitfield, is the Manager of Technical Services at MAPE. Jim received the honorary designation of fellowship from the Construction Specifications Institute in 2001 for his contributions to education in the construction industry. He is actively involved in the tile industry standards as the current president of the MMSA, which is Materials, Methods, and Standards Association. And he's an active member of the NTCA Technical Committee. Welcome, Jim.
Thank you, Jim. All right, good afternoon. Welcome to the seminar. Let's talk about exteriors. There seems to be a lot of participation, so I know that this is a very interesting subject at this time. Again, as Jim mentioned, this is an AIA type presentation. Talk about some of the learning objectives. Let's talk about the dynamics of the exterior installations and how to plan for success. How to specify with industry standards that are relevant to exterior installations. Understand the critical details such as flashing, waterproofing, tile and stone selection, sealers, mortars, grouts, etc. And learn the proper selection of stone, gauge porcelain tile, or porcelain tiles on an exterior and how they're affected by the environmental conditions. Why is there growth in exterior tiles? I don't know how much you're seeing it. I know in my position I get requests for exterior installations every couple days. They've grown like never before. And I think it's positive. I think it's very positive for the tile industry. But I think a lot of it's due to these larger panels, these gauge porcelain tile panels that are similar to the glass type panels that you see on buildings, or for that matter slabs, and provide a more contemporary new look. Again, the growth of porcelain tile panels and slabs have been a large part of the reason. And I'll also say that designers really like that, and architects for that matter, that good contemporary look that these large panels can provide, as well as just large format tiles. The substrates are better today. They're more bondable. We've got better mortars. The techniques can provide a good solid base for an installation of ceramic tile. At the same time, the methods of construction have changed quite a bit. And we'll get into more detail on that compared to what we used to do on exteriors good 20, 25 years ago. We'll touch on environmental conditions, tile and stone selection, substrates and substrates preparation, waterproofing, and way beyond waterproofing. Selecting mortars, grouts, concerns about efflorescence and sealants or movement joints. When it comes to environmental conditions, it really all starts with the weather and it ends with the weather. I'm not sure where you're participating from. I happen to be in Deerfield Beach, Florida. Beautiful weather here today. I suspect some of the rest of you are not quite in the temperature that I'm fortunate to be in today. But I grew up in Chicago. I spent 30 plus years in Colorado. Trust me, I know environmental conditions. And I'll use Colorado as an example. It's not uncommon to get up in the wintertime like this, and it's in the 50s as the day kind of warms up. That night it dropped down and snow substantially during the night. Next day, wake up again. It starts to melt, gets in the 50s, 60s, 70s, and all that moisture starts melting through the tile deck, if you might, maybe into the mud bed. And again that night, it freezes again. Very, very difficult and demanding on a tile installation. Let's talk about some of the other conditions. Windy. When we're doing exteriors and we're trying to make sure the mortars don't skim over, an extended open time mortar can be very, very beneficial, especially if you're in windy conditions. But more important, just protect the installation. Certainly a best practice is maintain heating or cooling during installation and cure, regardless of which is needed. You'll also notice that this large tent also has ventilation, which is critically important. Tenting is not something that we're used to in the tile industry, but all the other facade industries are. You look at installers installing stucco or eaves or exterior claddings in environmental conditions, again in cooler weather, or for that matter, driving heat. They're going to cover up those walls because they want to make sure they maintain as consistent of a temperature as possible so that they don't get inadequate drying or inconsistent drying for that matter. In our case, when we're looking at, again, large format tile, or for that matter, gauge porcelain tile, we're typically applying mortar to the substrate as well as the tile. Now, a typical gauge porcelain large panel tile could be 1 meter by 3 meters, or roughly a little over 3 foot by 10 foot in length. We're trying to apply that much mortar on top of the tile as well as on the substrate and keep it from skimming over. If it's open to the environment, the sun, the heat, the wind, those materials are probably going to skim over and you're not going to get a good bond. So protecting your installation can be critically important. Now, this is obviously a large commercial job and well protected. You might just have scaffolding running up to the parapet and a good visqueen over the back of it for that matter and tied off, etc., so that at least you're not getting the driving wind. But consider protecting the installation from direct sunlight, rain, wind, etc., not just during installation, for a good minimum 72 hours after installation while the materials start to cure. Make sure that the materials are used in the proper temperatures. Most cement mortars are recommended to be installed between 45 degrees Fahrenheit and 95 degrees. Can they take more? Sure. Your mortars really aren't going to freeze till you get about down to 32 degrees, but they stop hydrating around 40 degrees. So we want the best performance out of our mortars as you want the best performance out of our mortars on your job site. So really try to maintain the proper temperatures on the job site and it'll help your installation substantially. And again, the curing and protection times may vary depending on temperatures and the materials. If you've got an exterior cladding for that matter, and the temperatures drop down after installation, it's going to take a little bit longer to cure. If it gets too hot, they may go off too fast. In the case of a mortar bed on a wall, you're probably going to want to wet that down a few times before you start installing tile on it. So really, the temperatures can make a substantial difference, and keep that in mind during your installation. Talk a little bit about what it says in the code regarding porcelain tile. The International Building Code today, in section 1405, has exterior adhered masonry veneers. One section of that is porcelain tile. Today, the requirements are adhered units shall not exceed 5/8 an inch in thickness, nor 24 inches in any face dimension, no more than 3 square feet in total face area. Now I know I just mentioned tiles that are 3 foot by 10 foot. How does that fit into no more than 2 feet in any dimension? There's commonly some variances to this code, and many areas will accept larger tile. But let's finish out talking about the code requirements. They should not weigh more than 10 pounds per square foot. I'm sorry, 9 pounds per square foot. And of course, the tile must be adhered to an approved backing system, one that's code approved. Another part of the code that's relevant that most people aren't as familiar with is clearances. So on exterior stud walls, you have to be at least 4 inches above dirt. That's so that water's not weeping up behind your wall system. And not less than 2 inches above paved areas, so the water can weep out, as you see in this lower right-hand picture. This is an actual installation on a commercial project where water has got into the wall, and you can see how it's weeping out. Above that, you can see in this detail that we've got cement board. They've got a weep so that water can weep back out, and the tile, or in this case a stone installation, but same principle. Not less than ½ inch above walking surfaces that are supported by the same foundation. So we want to make sure that we don't have water going back in underneath that wall. I want to go back and talk about this for a second because, as I said, there's a lot of variances out there. A lot of cities will allow for large format tile with the proper weight, etc., assuming that they've not had bad experiences with it, to be quite honest with you. There is a group within the Tile Council of North America that is putting together recommendations for code changes to this section of the IBC. So the unfortunate part is if we go to the code change meeting, which is I think this year, I'm pretty sure this year, it'll still take a couple of years to get it implemented. Then of course, once the codes come out, they aren't automatically adopted by most cities, so once they get adopted by the area. So we are definitely going for larger format tiles, up to 4 foot by 4 foot, and in some cases, as I said, 1 meter by 3 meters. So that is being submitted to the IBC this year, or ICC this year. Tile selection. Think about the color. It can make a substantial difference. Of course, code compliance is always relevant. And that doesn't mean just the IBC, but your local code might have some requirements that aren't common to the IBC. Size requirements, the weight of the material, and slip resistance. This picture on the left just kind of gives you a rough idea in Celsius what the difference is between the water and, for that matter, the vegetation on the right in temperature versus what it is on that red road. Really about 14 degrees. It's about 84 degrees in the water and roughly about 98 degrees on the road. Obviously, if this deck to the right was pure black tile, it might be a little bit difficult to walk across with bare feet. So color selection can have a lot to do with the proper installation as well. Not that the others won't perform, it's just that it's going to be difficult to walk across under high temperatures. And slip resistance is obvious, if you've got a pool deck, areas that potentially could get wet, you certainly want to make sure you have the proper DCOF. Proper tile selection, make sure it's rated for exteriors. There's not a million, but there are a lot of different types of tests that are performed on tile. Make sure that you've got the proper abrasion resistance you're looking for, that you've got the proper absorption, that is recommended for exteriors, etc. Same thing true of the stone. There's a lot of relevant ASTM testing. Make sure that you know the absorption, the density, the compressive strength of the stone. We don't want to get crushed in areas that it shouldn't really be used. The modulus of rupture or bending strength or strength of that material itself. Flexural strength, cracking, abrasion, chemical resistance, and slip resistance. We really don't want to see decks like this. Obviously, this stone is not recommended for an exterior and is starting to spall as water gets into it, freezes, and blows the top off. Same thing in the lower left, and you see a lot of efflorescence on the right where the deck might not be draining real well. More than likely, that's one of the big issues. And for that matter, some dark colors can fade. If you put a polished black marble on the exterior of a building facade for that matter, the odds are pretty good in a few years, if it's taken a lot of UV on, it's not going to be a shiny black marble anymore. Make sure that the color you're using is recommended for an exterior. Talk a little bit about substrate preparation. In the case of exterior walls, we're talking about concrete, masonry, cement board, and I didn't really put it here, but really mortar beds as well. And they could be applied to either concrete or masonry, or for that matter, in some cases, frame systems. So a traditional, building paper, wire lath, scratch and brown, 3/4 of an inch sand and cement. Very suitable substrate. Important considerations for a wall: that the wall is flat and plumb, that it meets the surface preparation or tolerance requirements of ANSI, deflection, that they don't move too much, that's properly flashed. And I just happen to have a window up here in the upper right, but can't stress enough the importance of flashing. What you see in this area here is a sill flashing, and I've got a little bit better detail on that too. And of course, next is you're going to put in your sill flashing, your walls overlap by the top, and of course some sort of a flashing termination for that matter. Flashing is essential in all openings and is critical above tile installations. In some cases, I looked at a drawing today where tile is going to run right into an exterior insulation finish system. It needs to be weeped and a drip edge put out there so it can drain off the front, not into the wall system. Waterproofing is essential, and most important, be aware of the drainage, where it's going. Substrate preparation: you can have concrete, masonry, mortar beds, and cement board, common exterior decks for floors. Here's a little better picture of a sill flashing. This should be on your deck, of course, and this part A, if you might, over your waterproof membrane that's wrapping up the wall behind the finishes. This is a pretty heavy-duty deck, but certainly the only one that I know that performs well in freeze-thaw type climates. And what you've got is you've got a deck that's sloped. We've got a contact adhesive that puts down we've got a waterproof membrane, and that's applied with a contact adhesive. Then we've got another adhesive that holds a drainage system or a drainage membrane, a wire-reinforced mortar bed, optional waterproof membrane. I honestly would typically leave it out in most installations. Bond coat and tile. So water that gets into the grout joint, if you might, is going to get through the bond coat, into the mortar bed, into the drainage mat. Water always takes the path of least resistance, hit this membrane that's sloped 1/4 inch per foot, and ideally come out through the flashing. Important considerations for decks: slope to drain, whether it's on grade or it's suspended. Flashing, again, you'll hear that a lot. Proper waterproofing, and in my opinion, a drainage mat, certainly in any freeze-thaw climate, because we want water to take the path of least resistance. If, for instance, there was no drainage mat and this was sitting right on the concrete slab, the mortar bed, and we are in Colorado, as I mentioned, you got the daytime melt that's coming down into it, it freezes again, it's eventually going to freeze-thaw that mortar bed apart. So we want water to take the path of least resistance, give it air to go to, and move right back out of there as quick as possible. Water management is critical beyond waterproofing. If not, you commonly will have what we see here, erosion. I always recommend you follow the 4 Ds. Deflect the water, shed water by proper water management type systems, deflecting devices like eaves, overhang, and weathering devices, deflectors. You drain it by gutters, flashing, drains. One thing that's important when you're draining water off a deck, for instance, and it's going down the fascia of a suspended deck, where's the water going after that? Is it starting to discolor the front of the fascia? Maybe it's returning underneath that fascia and it's going to travel into an expensive finish ceiling. Take a good look at the drainage. Just getting water off the deck may not be enough. That the installation can dry. Is there proper ventilation? We want to make sure that we don't have moisture trapped. That has a means of evaporating. And durability, the suitability of the materials for the installation, meaning again the tile, the stone, the setting materials, the grout, etc. Make sure that they can perform through the life cycle or anticipated life cycle of that installation. When we talk about deflecting the water too, it can be very important to have devices like kick-out flashing. So if I have one roof, if you might, on a two-story building and a roof on a one-story building, I don't want that one-story building draining into the wall of the two-story building where my tile might be. You have to kick that water out away from the interior wall, or inside of the exterior wall, really. Talk a little bit about mortars. There's non-modified thin sets. This gives you a rough idea of how much they can move through thermal expansion contraction. 0.1 millimeter. Dry polymer modified thin sets. Your 118.4 single component mortars. 0.1 to 0.2 millimeters. Then you take a thin set in a decent acrylic. In this case, I actually happen to list the ISO S1 deformability being a standard deformability rating. 0.2 to 0.3 millimeters. Thin sets with flexible acrylics, ones that meet ANSI 118.15 and ISO S2 type ratings, 0.7 to 0.8 millimeters. So you can really get a rough idea of how much movement can be accommodated by the proper quality materials, which is very, very important on an exterior installation. To give you an idea, in freeze-thaw climates, the coefficient of tile is 0.2 and 0.4 millimeters. Can't stress it enough. Select a quality mortar. Some other things about mortars: make sure you should be back buttering on exterior applications. Check the materials for any dust, debris, contamination. Of course, in the case of stone, you can have the cuttings from the stone, or the stone dust for that matter, marble dust, or slate. The backing, the area where that's cut, you want to make sure that gets scrubbed. It can be almost an oily feel on the back of it. So, trowel in one direction. Notch it generally the short direction of the tile or stone. Push and pull the opposite direction to flatten it. Consider a quality mortar like an ANSI 118.15 improved modified dry set mortar. This is a new standard. This standard was only added about 5 years ago. So, high quality, high strength mortar. One thing that makes this mortar different than any of the other ANSI type mortars is that this one goes through a heat aging test where it's kept for 14 days at about 70 to 80 degrees. Then it's frozen for 14 days at, I forget the exact temperature, but it's frozen literally. And then it has to go through a shear bond test after the 28 days and reach 400 psi or better. So when it comes to 118.15 mortars, it's more than just adding more cement, more binder if you might. You also have to have a good quality polymer in the mix as well. Have respect for the water ratio to mixing. Follow the directions. Can't stress it enough. Allow for slake time and remix. That's important if you want to have water retention within the mortar, or I should say good open time. Exterior, ANSI recommends coverage of no less than 95% between the substrate and the tile. That means if we were to pick up a tile, we would see no less than, or I should say no more than, 5% voids. That's important. If you're in the freeze-thaw climates again, I remember in Colorado I went to a bank one time where unfortunately there was marble set in a panelization system by a drywall shop, and coverage was probably about 20%. They had to put scaffolding up over the front door and the back door of the bank just so people could get in and out without having to risk their lives. So if we have voids back there behind the tile and or stone, and water can accumulate back there, it can freeze just like a water bottle freezes when you put it in a freezer which means the water expands, pushing the tile away from the substrate, or unfortunately, typically breaking bond. Always try to achieve 95% coverage at a minimum. And check your coverage to make sure you're achieving that every once in a while. Unfortunately, there are some issues that we see on exterior installations, and we're going to talk about a few of them with mortars and grouts. With mortar, we'll talk about tile delamination, improper selection of mortar, spot bonding, lack of coverage, lack of movement joints, efflorescence, and latex leaching. Well, I don't need to tell you what the top picture is. It's of a very popular fast food restaurant that has a lot of latex leaching out of that wall. I'll show you some more on that in a minute. The bottom, unfortunately, it's a store in the Miami area, and the general contractor called me and said that they were losing tiles. The mortar wasn't bonding. So he sent me some pictures. It's probably 4:30 at night, 5 o'clock when I'm trying to get out of the office. Last minute I'm downloading some pictures from the job site. When I looked at the pictures, I noticed that they're all spot bonded, and these tiles were roughly 2 foot by a little over 3 feet. And I suggested he close off the sidewalk. Now trust me, that didn't go over too well. When I told him that there was a safety issue and he shouldn't allow people to walk underneath that area, that did not go over real well with the GC. But it was critically important to this installation and that people are not allowed to walk underneath it, because unfortunately these tiles are falling. Let's talk about spot bonding. The top picture is a memorial this picture was taken in Miami. Looks like they had great waterproofing on the right there. Unfortunately, it was spot bonded, and this expensive stone was falling off, I think, before they even got the museum open. The lower one, I see a picture like this every 3-4 days. Exterior installation of stone and spot bonded. Exterior tile should have at least 95% coverage, as we already talked about. Spot bonding allows for poor impact resistance. You can imagine if there's voids back there, if it was to be point loaded or kicked it for that matter in the right area, it would just fracture. Poor load resistance and moisture issues. Moisture can accumulate in all those voids and just discolor the stone or tile for that matter. This is a big, big issue. As tiles become larger, installers don't do the proper substrate preparation. They really don't know how to flatten out a wall other than put more mortar underneath the corner. This works okay for some of the masonry industry, but not for the tile industry, not to mention large format tile. Oh, this is a video, and I apologize. It's not a live link, so I don't, well, yeah, we're not going to see it go launch, but this is a project up in Northern California. This whole exterior of every one of these houses, 100-some homes, it has porcelain tile done, spot bonded, and these million-dollar homes, people are being told not to walk underneath their walls because tiles are falling off. This happened this year. You can look it up on YouTube for that matter. Tiles delaminating in Northern California, and I'm sure this will pop up on multiple news channels. It's a very, very unfortunate thing. We didn't have an opportunity to put these tiles in installations like this in the past. We lost this to other types of finishes. Now we're getting them, and we're doing them wrong, and that's unfortunately starting to cost us as a tile industry. If we don't get this corrected, we'll lose all tile on the exterior installations. Lack of coverage, poor troweling techniques, skimming over the mortar, as I talked about earlier, because maybe it's open to the wind. In properly prepared substrates, it's critical. You should be 1/8 of an inch in 10 for anything over 15 inches on one edge. Poorly keyed in substrates, you want to make sure that the mortar is keyed into the substrate well before you start notching. And again, as we talked about a little bit earlier, you really should be notching one direction and pushing and pulling in the opposite direction so we get it good and flat down. No swirling, as you see in both of these pictures. You can see how that tile came off. It looks like it wasn't even touched in the bottom. Of course, not implementing 95% ANSI required coverage. Lack of movement joints. I've always said either you place them or Mother Nature will, but they're going to be there. So for exteriors, they should be every 8 to 12 feet. But in this case, we got a little bit of everything. We've got the expansion of the tile. We've got a little bit of spot bonding. We've got a big failure. The stone is expanded to the outside retaining areas so much that it's actually started to crack apart. Obviously, this is brick in this lower right-hand corner, but it kind of gives you an idea how much movement is critical. Per the TCA handbook, method EJ171, movement joints should be every 8 to 12 feet in each direction. This allows for thermal and moisture expansion and contraction. This drawing was recently added so you've got perimeters, which is obvious. We've got interior movement joints and exterior corner movement joints. That's only required on exteriors, but I stress that because it's important, and that's why this drawing was done, because it's important. Talk a little bit about grout. There's standard cement type grout, sanded, unsanded, and of course high performance ANSI 118.7 type grouts. There's the installation of grout, some of the important ANSI standards, and of course the ISO designation for cementitious type grouts. There are others that might be recommended exterior, by the way. Many manufacturers recommend epoxy exterior. I know some of the lighter colors typically have a tendency to discolor or not retain the same color over time. And ready-to-use mixed grouts may be recommended exterior as well. But I'm going to talk about cement today because I think generally for most manufacturers that's the best choice. The ANSI 118.7 high-performance cement grout, typically not cement-based, or at least Portland cement-based, using calcium aluminites. They're ideal for exterior installations. Faster setting. Little to no susceptibility of efflorescence. Efflorescence is water-soluble alkali that comes out of Portland cement. And if there's no Portland cement in there, it can't come out of the grout. I will say that if not properly weatherproofed, etc., and efflorescence is generated by the setting material or the substrate, it still can come through even the high-performance grouts. Lower porosity than standard grouts, less than 5% porosity, and better color consistency and resistance to staining. An ideal choice for exteriors. Has less shrinkage, lower water absorption, can be submerged in 72 hours. Check each manufacturer to make sure of their recommendations. Higher compressive, tensile, and flexural strength. Most manufacturers today make a universal formula, so it's used for grouts from a 1/16 of an inch up to 1/2 inch or 3/4 of an inch. I always recommend if the grout has an aggregate in it, even regardless of how fine that is, that you test it against some of those sensitive finishes like glass and stone. Make sure it's not scratching it. Efflorescence, pretty common in cementitious grouts, especially used exterior. You commonly see it in colder weather where The moisture doesn't migrate out of the cementitious grout in a normal rate because the temperatures drop. The water seeks salts out of other materials. Again, could be the substrate, could be the setting material. When it warms up, the water evaporates and leaves this mineral behind, or white alkali, water-soluble alkali material. The upper picture you see is a hot tub in Aspen at a hotel. Pretty efflorescent, I will say. So generally, efflorescence comes from a moisture issue. It's water-soluble alkali, so if moisture is present or if there's excessive moisture there, when it does evaporate away, you'll generally see this mineral or salty type material left behind. It could be contaminated aggregate. You could have a mortar bed that's installed that the aggregate was just full of salts and mixed with the cement. Then you install the setting material, grout, etc., and all that moisture from the mud bed comes up through the grout. Mixer cleaning the grout too wet can also affect this because it extends the open time and really puts this material into solution. It's cleanable generally, but not fun. Latex leaching is something we're seeing more and more of today. And the reason for that is the type of construction we do today is very different than what we did 20, 25 years ago. Today, we're putting up typically frame construction, cement board, waterproof membrane over it, a low absorption porcelain tile over the top of it, a good latex polymer mortar to set that tile over the top of that waterproof membrane over cement board. If the parapet cap's left open, if the roof leaks into that area, I've seen some fast food stores where the roof membrane runs into behind the tile. All that will fill up with water, and the only way for that water to get out is through the grout joint, taking some of the latex with it. Think about latex leaching like this. If I took a gallon of latex admixture, put it on my desk, took the top off it, the water would eventually evaporate away to where I'd have a little ball of latex at the bottom of it. If I kept the lid on it and the latex stayed into solution with the water, it'll always remain a latex liquid solution. If the latex in a mortar or grout is not allowed to dry, it can't become a solid, so it is water soluble. When water leaves that installation, it'll take the latex with it, allowing it to leach, if you might, to the exterior. What you see in this upper left-hand corner is a water feature in Maui. I had to travel far to get this picture, but they obviously filled this water feature too quick. So the latex in the mortar and or grout dried at the very top surface of where the water level is. So water is terminated right here, and the latex dries right along the top of it, obviously allowing for the water to move. I do not know why this latex is leaching down the face of the stone, but I'm going to assume that there's a leak somewhere up above here. And the same thing is true of this on an exterior commercial installation, where water's got in because the parapet cap wasn't put on at the proper time. Water filled the cavity between the tile and the waterproof membrane, allowing it to come back out through the grout joint. It is not fun. It's not fun to clean up. It's just like trying to clean up a diluted paint, if you might. But we see this a little bit more today with cement board installations than we did years ago when we put a mortar bed up. So in this case, if this was a mortar bed, it would have been sand and cement over a building paper for that matter, metal lath, 3/4 of an inch. It drains from the very, very top all the way down through the bottom and back out. But when we put cement board there with a waterproof membrane, there's really the only thing to allow it to drain through is a low absorption latex polymer mortar. So we're seeing this a little bit more. Like I said, check for leaks. Make sure that there's coordination between the tile company and the construction company, that the roof material, if you might, gets over the top of it, that you've got drip edges where you have terminations. If they put signs in your wall, make sure that that's properly sealed before they start attaching the sign. At terminations with right returns, make sure there's a drip so you don't have it returning all the way underneath that right area or underneath the soffit for that matter. Any areas that drain poorly or if sealants aren't installed properly, you're going to have issues. Here's an exterior on, again, one commercial project. They just stopped the tile with a cement board over the waterproof membrane here. You can see the top of this cap doesn't really drain all that well. I mean, this is overlapped. You can see where there's no sealant where the cap flashing goes up against the tile, nor where the tile butts the building. The roof membrane has a tear in it. This comes up over the parapet and then right underneath that flashing. You can also see here where water's in the wall, not just in the tile installation on this project, but obviously also in the whole wall system because it's just not properly detailed. This parapet cap, in my opinion, should come over the whole parapet, not just this area, because you can see where there's a gap there. And you can imagine how much water is getting in right there. How about this area where it drips going right into the wall? This is one project. We see things like this on a lot of exteriors, unfortunately. Movement joints. Follow the current ANSI A108.1 or A108.2 recommendations, as well as TCNA EJ171. In 2017, the TCNA handbook added additional guidance on size and frequency for interior movement joints. Exterior movement joints can be spaced no more than 8 to 12 feet apart in both directions. We want to allow that installation, if you might, to expand and contract. And I'll also mention movement joints need to be properly installed. What I mean by that is if this joint right here is, let me grab its pointer, I'm sorry. If this joint is filled 7/8 of the depth with mortar and not open, that installation is not going to expand and contract regardless of how flexible this sealant is that's installed over the top of it. And I see that frequently. So these joints should be open as much as feasibly possible, certainly the depth of the tile, and filled with sealant over a backer rod. In summary, exterior installations are not like an interior project. There's a large variety of things to consider. Again, drainage. Where's your water going when it's draining? Is it going down the face of the building, down the fascia, discoloring it? Make sure you have a place to drain that water. Do you have a deck, for that matter, that runs into scuppers that are ½ inch or an inch too high? It's not going to drain. If the flashing's not lower than the membrane, the waterproof membrane, it's not going to drain. It's going to accumulate right there at the edge of the deck. Keep those things in mind. Protect the installation from weather. Don't install in bad conditions. Try and keep the control of the temperatures and the weather and the job site as much as possible. Water management is essential. You've got to keep water out of an exterior installation or you are going to have all kinds of discoloration, whether it's efflorescence, latex leaching, or for that matter, if poor coverage, you're going to have a failure. It's just going to start popping off the wall. Make sure you've got mortar coverage. Spot bonding is not acceptable with cementitious mortars, period. You must have 95% coverage. Check that at the beginning of your installation, lift the tile back off, and check it a few other times to make sure you're achieving good coverage and that your methods are solid. Use quality mortars recommended for exteriors. Again, I personally would recommend a 2-component, one that meets ANSI A11815. Make sure movement joints are frequent and properly installed, every 8 to 12 feet in the full depth. Make sure that everything is well cured, a minimum of 72 hours after installation in 70-some degree temperatures before exposing it to the environment. Thank you.
Jim, great job. Great job.
Thank you.
Fantastic presentation, and I'm certain our audience appreciates your expertise and knowledge on this topic. But it gets me thinking, you know, everything I heard you talk about reinforces the fact that training and education is very important. And I just wanted to reinforce the fact that all the manufacturers have technical help that can help you with your decisions and information you need to do the job correctly. And of course, the NTCA will give you all the methods and standards and correct information. Go to our website at tile-ASSN, check out our training workshops. We have an NTCA online university. Check that all out. Get educated. Get all of your installers educated and your lead people. It's very important. I just wanted to say that, Jim, real quickly. We do have a couple questions, and let me do this real quick. We're going to go back to slide number 23 right here. And I have a question that says millimeters per what? When you say 0.1 millimeters, what are you talking about? Millimeters per what?
Per metrics? So this is not even a millimeter. It's less than. So a typical thin gauge porcelain tile is 3 millimeters.
Are you talking about movement though, or are you talking about?
Oh, I'm sorry. Yes, expansion, contraction. How much they're allowed to move? Yes.
Correct. That's all I want. I mean, they asked the question. I knew the answer, but I just wanted to help you out there.
Sure.
That
correct.
Is movement. That's your movement.
And that's pretty minimal, but it's still relevant.
Yes, exactly. And it's very, you know, think about that though. That actually, when you have a huge wall like that, that adds up to be a lot. So, you know, that's very important.
And more important, if you've got a tile moving in freeze-thaw climates, and again, these are general numbers, but still, and you can imagine if you just have an inexpensive dry polymer modified thin set, it may not perform as well as the tile wants it to. That's not good.
Right, exactly. So to further his question, he said, so 0.1 to 0.08 millimeters per 8 foot or meter. At the bottom where, you know, it says is approximately 0.2 millimeters to 0.4 millimeters per foot per what? I mean, what is that movement? That's the total.
I could not answer that. I'm sorry. I apologize. I could not answer that.
Tell you what. So Chip, we'll get back to you on that. We'll do a little research and get an answer for you on that.
Chip, you know my number. Call me.
Yeah, Chip can call you direct. That's true. He can. He also asked a question about how would you handle exterior outside corners, and I think you mentioned it in one of the slides about using expansion joint, right?
Correct.
But
Correct.
Is that how you handle all exterior outside corners with expansion joints?
They should be, yes. Exterior should have expansion joints, as detailed in the TCNA handbook.
You had it right there, right now.
Yeah. And that's directly out of the handbook.
Yeah.
And again, I'll stress, exteriors only.
Yeah, no problem. And Chip said he'll call you later, just real quickly.
There you go.
And I have one more comment to make. So I want everyone to know that the Ceramic Tile Education Foundation has ACT programs and CTI, but they have an ACT certification, so Advanced Certified Tile Installer Program has a certification for installers for large format tile, membranes, and gauge porcelain tile. Go to CTEF, Ceramic Tile Education Foundation, and do some research. There's a lot of education that needs to be taught and learned. So everybody, we can all continue learning. So that's all we have today, Jim. You did a fantastic job. I want to thank everyone for attending. I think this was a great presentation and gave a lot of information into, more than anything, probably some pitfalls and some challenges that are out there in exterior installation. So thank you very much.
Thank you. Thank you for joining us.